Hello there, folks. There's two types of probability. There's actual probability and theoretical probability. The actual probability is when you're conducting an experiment and actually what's happening. So, this is during an experiment, the probability of an actual experiment. So if I flip a coin twice and it comes out heads both times, the actual probability of getting a head is 100% because that's what happened. All right? So actual probabilities can differ from theoretical probabilities more and more. However, the more samples you take or the longer the experiment, the limit will actually, that's a calculus term, okay, the actual probability will approach the theoretical probability. I don't know if you knew that. So if I took that same coin and I flipped it 10 times, it's going to get closer to the theoretical probability. If I did it 1,000 times, and I think students need to see that either through a computer-generated coin flipper or program, and they need to kind of see that. And I would put up there the actual probability and see what happens. I mean, out of 1,000 times, you're expecting it to be 500, but it's, it gets closer and closer. Sometimes it just never is exactly the same. The theoretical probability is defined as the number or I like to say like number of winners, and I put winners in quotes, like over the total amount of choices. All right, probability scares lots of teachers because I don't know if they understand it or don't understand it. It's a pretty easy concept. For example, in a coin, all right, if we're talking about a coin, we have two possibilities. There's two outcomes. If you want heads, that's 1 out of 2. If you want tails, that's 1 out of 2. So for a coin, it's the number of winners, what you want. The probability, which is 1 or the head or the tail, over the total amount of choices. So if I was doing a classic problem, here's a classic problem. I have 2 reds, and you can do this with the students. You can do it with M&Ms. An M&M thing is great as long as they don't eat them all. You can have something like this. Okay, let's say this is a classic problem. All right, these are classic, and I'll call them marble problems. All right. The old marble in the sack, pull out 1, what do you get? So if I put all these marbles in a sack, what's the probability? And you might see it like this. I mean, higher level of math, you might see what's the probability of green. Okay? Well, there are a total amount. Your total choices are 1, 2, 3, 4, 5, 6. And there's 3 green. Okay? Now you can even get into some fraction, and this can happen after maybe you talked about fractions. We can simplify that to 1/2. Fraction simplification is kind of a tough thing to teach. You have to know something about greatest common factors. You can divide both of these by 3, and that's your greatest common factor. So you get 1/2. Then you can do the probability of blue. And one of the things that is very important that the students understand is that theoretical probabilities, all these are numbers. They're all decimal numbers. All right? The decimal number of 1/2 is 0.5. I know I showed you 1/2 twice. Let me give you another example here. The probability of red, just because I have to be a little different, is 2 out of 6, which is 1/3. 1/3 is 0.3 repeating. Okay, so all these probabilities always range between 0 and 1. And I think it's important to ask students if they can give you a probability or let them tell you a situation where a probability may be 1. Like, for example, they'll have a meal today. What's the probability they will eat a meal? 100%. Okay? 0 may be something like, what's the probability that, you walk in and your eye color changes? 0. Your eye color, well, I don't know, maybe hazel eyes or something like that. But you get my point here. Or the probability of choosing a black marble, okay, from this bag. Well, there's no black marbles. So the answer is 0 out of 6. All right? That's even a better example. So that's your theoretical probability. That's your actual probability. And I just want to show you some things that exist out there. We did coins. Okay, I'm good with coins. And one of the things, I mean, your higher level students, I'm talking to maybe the 7th grade, 6th, 7th, and 8th grade teachers, your higher level kids, if you took 2 coins together, now how does that affect the probability? Well, if you have one coin, let them list the sample space. Okay, this is called a sample space. All right? A sample space is a list of all possible outcomes. So if I'm going to call this coin 1, and then I'm going to call this coin 2, all right, what can actually happen here? All right, coin 1 could land up on heads. Coin 2 can land up on heads. All right. Then what else can happen? Coin 1 can land on heads. Coin 2 can land on tails. And this is a sample space. We are building a sample space. And if the students don't do a sample space, then they really don't understand the problem. So really, your first level of understanding to measure is this sample space. All right, I always have questions on probability tests and quizzes that say, just give me the sample space before they do the probability. So then what can happen? Well, this can come out tails. This one can come out tails. And then you can say, well, this could come out tails and that could come out heads. And you notice that there are 4 possibilities. So so you can ask many questions about this. What about getting 2 heads? Well, it's 1 out of 4. A tail and a head, okay? At least 1 tail. So you can, just by questioning, you could change the whole way that you look at probability. But that's your sample space. Speaking of sample spaces, that runs right into my next thing, dice. There's a cool little program, by the way, I have here, because you can have kids roll dice. 1, and this one will actually say it.
1.
See? So I rolled 2. I can just keep clicking it to roll. So the kids can have a lot of fun with this. All right? Notice I put my two dies, or my pair of dice, in different colors. I think that's very important. Because if you're going to continue to do the sample space on a pair of dice, well, now you have to ask the kids what's the highest number they can get. What's the lowest number they can get. Hopefully you can get 2 and 12. We can even go back and say, what's the probability of getting a 1? There's 0 again, okay? What's the probability of getting 13? Well, now they're not all the same here, all right? I would actually start with 1 die and go up, as all of them have 1 out of 6. And I'm talking a standard die here. I understand there's like different sided dies and stuff. And that's something to talk to your kids about. You know, they used to have a game called Dungeons and Dragons eons ago that had different side dies. Well, here, if we're going to do a sample space, and usually you sum them up. So the sides of the black die are 1, 2, 3, 4, 5, 6. The sides of the blue die, 4, 5, 6. And what you do, or what we do when we're doing dice here, is we're adding them up. So you'll see everything in here will be my sample space. So you'll see what happens here is that as I go through this, there's a lot of different ways and different combinations. That's my discrete mathematics, but there's a lot of different combinations on how to get And by the way, lined paper does a great job here, unlike what I'm doing. All right, but lined paper really helps out. And you have the kids do this. They need to do this. This is a classic problem you will see even even at the high school level. So you'll notice there's 36 combinations. They can list them out. Which one has the most? 7. 7 comes out 6 out of 36 times. Your probability of rolling is 7. That's why in some games 7 is big, like craps or something. All right. I think they might be a little too young to be talking about gambling, but just for you to know. 6 and 8 have the same. 5 and 9 have the same. These are questions you can ask them. Which one has the least amount? And hopefully they say, well, 2 and 12 have the least amount. Okay? So, there you go. So a little probability, but the sample space, very important. Another classic probability question is spinners. They love this. Spinners. And here's another application. Look at, you click and it spins. Okay? And I bet you can really make different colors, okay? You can have the spinner have 5, 6, 7 colors here, okay? And we can spin it up. And now that you see there's 2 reds, okay? So if it has a better chance of landing on red, in this case, in your spinners, it's how many pieces of pie. It's actually the area of pie, but they're all the same area. So you figure 1, 2, 3, 4, 5, 6, 7. Out of 7, red landing on red, or the probability that it lands on red, is 2 out of 7. Okay? Probability that it lands on any other color is 1 out of 7. Okay, so red has the best choice. And here, I can sit here and I can click it, and good things can happen. Okay? And it doesn't hang. So there's where the actual probability and the theoretical probability are totally different. I just rolled 2, and I got blue and brown or black here. All right? But that's what you have to know about probability. If you have any questions, you'll see me soon, and we'll get you set up on probability. There's a lot of different cool things with horses and things like that. Cards, okay, cards, especially your deck of cards. I don't think they do that on standardized testing anymore because they don't think everybody has enough experience with cards. So that's why I didn't show you any. But just here, I'll write you some facts about some cards, a deck of cards, a standard deck of cards. There's 52 of them. There's 4 suits, 4 suits of 13 cards. Okay, 4 suits. There's 13 cards each. And the cards range from ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay, especially if all these kids are into computers and stuff, card games are really, really big. Blackjack, things of that nature. So you can ask them questions like, what's the probability of getting the ace of spades? It would be 1 out of 52. There's only 1. What's the probability of getting an ace? 4 out of 52. That'll simplify to 1 out of 13. All right. What's the probability of getting a number above or below something or in between? So those are all types of easy probability questions that you guys can answer. Like I said, with cards, I don't think it's standardized anymore, so that's why I really don't do it anymore. All right, in my next video, you'll see a little bit of discrete math and some number theory. It'll be a quick one, and then we'll get right into algebra.